Yellowstone's Biscuit Basin hydrothermal eruption sparks. Scientific curiosity over magma shifts beneath the surface. June 2025, Yellowstone National Park. On the cool, quiet evening of May 31, 2025, the serene geothermal landscape of Biscuit Basin in Yellowstone National Park was abruptly interrupted by a hydrothermal eruption at the Black Diamond Pool. Unlike the violent steam explosion of July 23, 2024, which hurled rocks and debris over 600 feet into the air and shattered wooden walkways, this event was more modest yet no less significant to scientists. It sent a 20-30-foot plume of steaming water and debris skyward, caught on newly installed surveillance and thermal imaging equipment. Though no visitors were injured and no infrastructure was damaged, the 2025 eruption has deepened concerns among geologists and volcanologists.
Really gas-rich, volatile-rich cap on top of the magma chamber.
It's not merely the visible eruption that has their attention, but the invisible signals pulsing from beneath Yellowstone's surface, particularly under what scientists are now calling the hydrothermal garden, a term used to describe the interconnected geothermal zones of Biscuit Basin, Upper Geyser Basin, and beyond. A breathing garden of steam and magma. Hydrothermal eruptions occur when underground water, superheated by nearby magma, flashes into steam and violently expands. These events are sudden, often unannounced, and can occur without any prior seismic activity. But while the May 2025 event appeared calm compared to the 2024 blast, it came amid an uptick in deep seismic tremors and subsurface temperature anomalies. According to the US Geological Survey, USGS, the deeper concern lies beneath the hydrothermal garden itself. State-of-the-art seismic imaging conducted throughout early 2025 has revealed a slow and subtle shift of magma inside the massive underground reservoirs that feed Yellowstone's heat. July 2024. A warning echoes beneath the park. Back on July 23, 2024, the hydrothermal explosion in Biscuit Basin startled not just park visitors, but also monitoring stations.
Shit! Run!
In its aftermath, seismologists detected changes in low-frequency earthquakes beneath Steamboat Geyser and the Yellowstone caldera. These tremors, described as deep, long-period events, often indicate the movement of magma and pressurized fluids through the crust. In the months that followed, seismic arrays detected the slow migration of molten rock beneath the northeastern section of the park, a creeping motion just several kilometers below the surface. Near the Mallard Lake Resurgent Dome and extending toward Norris Geyser Basin. This movement is not indicative of an imminent eruption, but it does suggest that the system is recharging, adjusting, and breathing. May 2025, Black Diamond Pool and the Magma Pulse. The May 31, 2025, eruption at Black Diamond Pool came precisely as deeper sensors were picking up renewed signals.
And geyser activity that occurred over the past month.
Small but detectable ground deformation increased degassing, especially of CO2 and SO2, and localized heating in the crust under Biscuit Basin. Scientists now believe that the same shifting magma body responsible for energizing Steamboat Geyser and the 2024 eruption may be contributing to changes in the underground pressure in the hydrothermal garden. The magma is not rising rapidly, but it is moving laterally, spreading slowly and reshaping the intricate system of fractures, steam chambers, and fluid pathways beneath the geysers and hot springs. This geological ballet is not unusual, but its timing, paired with multiple hydrothermal explosions in less than a year, has captured the attention of scientists who monitor Yellowstone's volcanic system around the clock. What lies beneath the magma cap and its role? In April 2025, scientists published groundbreaking research identifying a magma cap beneath Yellowstone. This cap, a layer of hot, semi-solid rock laced with gas and crystal mush, sits approximately 3.8 kilometers, 2.3 miles beneath the surface. It acts as a regulator, allowing pressure to be vented gradually through cracks in the crust. This cap is not new, but it is changing. Seismic reflection studies and underground imaging indicate that magma is actively shifting beneath the cap, sometimes pooling or migrating toward the edges of the caldera system. While this movement is not alarming in itself, it provides critical context for understanding how surface events like the Biscuit Basin eruption are tied to deep geologic dynamics. The hydrothermal garden, living on borrowed heat. Biscuit Basin is part of Yellowstone's hydrothermal garden, a lush tapestry of boiling pools, erupting geysers, and sulfuric mud pots, all powered by the supervolcano's immense heat reservoir. Each eruption, no matter how small, tells a story of energy transfer from magma to water, of pressure release and subterranean change. As magma continues to shift and evolve under the garden, scientists are closely monitoring for signs that could herald larger or more frequent hydrothermal explosions. The key, they say, is understanding how magma movement influences pressure in the shallow systems and how quickly those pressures can turn explosive. Final word: the system is alive, not imminent. Despite increased activity, the USGS maintains that Yellowstone remains at normal background levels. There is no indication of impending volcanic eruption. But the back-to-back hydrothermal events, 2024 and 2025, coupled with shifting magma signatures beneath the park, are a sober reminder. Yellowstone is alive.